Okay, everybody, this is going to be section 3.2. The entire section is pretty much going over factoring techniques, which is things that we're going to need to be able to do in order to solve some problems in later sections. So for the most part, I'm going to be going over just a bunch of examples in this video. That's pretty much what we're doing. So we're going to be going over um, factoring. I'm not even going to write the word because it's all factoring. We're going to factor the difference of squares and the sum and difference, learn how to spell, and difference of cubes. So that's one thing we're going to do. We're going to learn how to factor perfect squares. We're going to learn how to factor second degree polynomials. We're going to learn how to factor by grouping. And by learn, I just mean we're probably going to relearn some of this stuff because we've kind of done some of it before. We're going to factor second degree polynomials where you have a coefficient greater than 1. So let's say where a is greater than 1, where a equals 1 for that one, I'm not going to add a whole another one. We're just going to say and a is greater than 1. So two different types of polynomials, second degree there. Basically, those are quadratics. And then the last thing we're going to talk about is this concept called completing the square. Okay, so the concept of factoring. First of all, a factor. A factor is literally something being multiplied by something else. That is a factor. So when we have something that looks like this, 2x plus 3 times x minus 4. These things on the left-hand side of the equation are factors. The 2x plus 3 is a factor, the x minus 4 is a factor because the quantities of both of those are being multiplied together. When you multiply those out using whatever method that you know, the FOIL method, the box method, the distribution method, it's all the same thing, it's just different names for it. You should end up with 2x squared minus 5x minus 12. So factoring something is just taking the right side and going backwards to the left-hand side. That is the general idea of what we're going to be doing. So the first thing is we're going to have to identify what it is that we're looking at. You know, what type of an equation am I given so that I know kind of what thing to use. So the first one that we talked about on here was factoring the difference of squares. So if we're going to factor the difference of squares, so this will follow number 1. The overall general concept is that if I have something squared and a minus sign, then hence the difference, minus another perfect square. The factors of this will always be a minus b and a plus b. Those are the factors of the difference of squares. Doesn't matter if you do the a plus b first and then the a minus b, that doesn't make any difference. But those are the factors of difference of squares. So let's do an example of that. So let's say that we have x squared minus 4. Well, x squared minus 4 is a difference of squares because x squared itself is a perfect square of x, because x times x is x squared. 4 is the perfect square of 2 because 2 times 2 is 4. And we have a minus sign in between. Therefore, it is the difference of squares. So that will factor to x minus 2, x plus 2. The biggest thing is knowing your perfect squares, recognizing the perfect squares. I would highly recommend, if you don't already know this, to create yourself maybe a chart. You should probably know your perfect squares up through at least 12. So you need to know 1 squared, 2 squared, 3 squared, 4 squared, all the way up probably through 12 squared. That's really going to help you to recognize a lot of these things. Any variable that has an even exponent is always a perfect square, because the square root of any variable with an even exponent is just going to be that same variable and then half of the exponent. So for example, x to the 6th, the perfect square root of x to the 6th is x cubed. It's half of that 6. So x cubed times x cubed would give you x to the 6th. So that's just kind of a good look for there when it comes to perfect squares. I think that the perfect squares are probably one of the easier ones to do as long as you recognize your squares. Let's move into the sum and difference of cubes, though. Those are a little bit more challenging to do. So, the sum and difference of cubes. This is still all part of 1. If I were to have a cubed plus b cubed, okay, a is obviously a cubed is a perfect cube, b cubed is a perfect cube, and there's a sum on in between. This one is a little bit longer, and if you have to memorize it, you're just going to have to find a way. I'll tell you how I think about it, and you can figure out whether that works for you. The first thing I do is I know that when I factor the sum or the difference of cubes, and you'll see that these are almost identical, there's going to be a binomial times a trinomial. So I'm going to leave a little extra space there for the trinomial. The binomial part, that's probably the easiest part. The binomial is take the cube root of the first term and take the cube root of the second term. That's what goes into your first parentheses. So the cube root of a cubed is a. The cube root of a positive b cubed is plus b. That's the first parentheses. To get the second parentheses, the trinomial, I actually work from here. I go from this one. To me, it's easier. You can figure out whatever way works for you. So what I do is I know that the first entry in my trinomial is this piece squared. So a squared. The last entry, so over here, of that is going to be the second piece of this binomial squared, b squared. So the first and the last piece is just the square of these two things that we've already gotten in our binomial. The middle piece really isn't that hard. You're just going to take both of these two pieces, multiply them together, and then change the sign. So in this case, it's going to be a times b, but I'm going to change it to a minus because of the fact that it is a plus in here. So it's minus a times b. Don't forget my plus at the end. So that is the sum of cubes. Like I said, if you can figure that one out, the difference of cubes is almost identical. It's actually the exact same pattern. It's a cubed minus b cubed. The exact same thought process works. I am going to take and set up a binomial times a trinomial, take the cube root of the first term, which is a cubed, take the cube root of the second term, that's minus b cubed. Remember, you can take the cube root of any positive or negative, so that's going to end up, that should not be a cubed, I apologize, it should be a. The cube root of minus b cubed is just minus b. Now I go from the binomial. Square the first term, a squared. Square the last term, negative b times itself is going to give you a plus b squared. Multiply these two things together, and then change the sign. So a times negative b is negative ab, but we're going to change the sign so it'll become plus AB. That's it. That's how you factor the sum or the difference of perfect cubes. So again, let's go ahead and do a couple of examples. We're going to keep these relatively easy for the most part. So for the sum of cubes, we're going to do x cubed plus 8. X cubed plus 8. Now, I don't think you need to worry about getting your perfect cubes all the way up to 12. I would definitely know your perfect cubes. I would say up to 5. So you should probably know what 1 cubed, 2 cubed, 3 cubed, 4 cubed, and 5 cubed are. That's going to really help you as well. Otherwise, these numbers get really big. But we're going to keep this small. So x cubed is the perfect cube of x. 8 is the perfect cube of 2. 2 times 2 times 2 is 8. So to factor this, a binomial times a trinomial. Cube root of x cubed is x. Cube root of positive 8 is plus 2. Now I'm going to go from the binomial. Square the first part, x squared. Square the last part, plus 4. Multiply the x times the positive 2 and get 2x, but change the sign. Minus 2x. That is now factored. So once you get the pattern down, it's actually pretty easy to do. Okay, let's try one with the difference of cubes. So x cubed minus 1. Same exact idea. Binomial, trinomial. Cube root of x cubed is x. Cube root of negative 1 is negative 1. Go from the binomial now. Square the first term, x squared. Square negative 1 plus 1. Multiply the x times the negative 1, which is negative x, but change the sign to plus. That's it. We have factored the difference, the difference of cubes. All right, again, I hope that that is not too difficult to see. What makes this more difficult is when we start throwing extra coefficients and things like that out in front of all these things. So maybe, let's just do one more example of a difference of squares. The sum of squares, by the way, cannot be factored. So if it's a squared plus b squared, that cannot be factored. That's actually considered prime. We'll talk about that later. But maybe you've got, let's just do one more example here. Example 64x to the 4th minus 25. So you do have to recognize, okay, 64, that's a perfect square of 8. 25 is a perfect square of 5. Is x to the 4th a perfect square? It is, because it's got an even exponent. So all of these are perfect squares, and there's a difference or a minus sign in the middle. It will factor, it will follow the pattern. So that is going to be square root of the first one, which is 8x squared, square root of the second one, which is 5. That will be in both parentheses. One will get plus, one will get minus, and the order of that doesn't matter. That's it. So again, the biggest thing is recognizing your squares, recognizing your cubes. All right. Now let's see if we can factor what is called a perfect square trinomial. So we're going to factor perfect square trinomial. So this will be the second of our topics. A perfect square trinomial is called such because when you factor it, you end up with the same binomial twice. So a trinomial just means that it has 3 terms in it, as we've been using. So let's say that we have x squared plus 6x plus 9. Okay, this is a perfect square trinomial. And there is a way for us to be able to figure this out, whether it is or not. If you were to factor this, you're going to end up with x plus 3 and x plus 3. And I'll tell you how we get to that in a second. which is the same thing as x plus 3 squared. So hopefully now you can see that that makes a perfect square. X plus 3, the quantity squared, is now a perfect square. So the question is, how do you figure this out quickly and easily? So a perfect square needs to be in this form. A squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. If it's in one of these two forms, they will factor into a perfect square. So the first one will factor into a plus b squared. The second one will factor to a minus b squared. So here's your check. Here's what you want to look for. Let's go back to the example that we just did. Is the first term a perfect square? Yes, it is. X squared is just the square of x. Is the last term a perfect square? Yes, it is. 9 is the square of 3. If I take 3 and x, multiply them together and double it, do I get that middle term? 3x doubled is 6x. This is a perfect square trinomial. It will factor very, very easily into what we just did. So let's go ahead and try another example, maybe one that's not quite as obvious. Let's factor 9x squared minus 6x plus 1. Let's first of all check to see whether this is a perfect square trinomial. The first term, 9x squared, that is the perfect square of 3x, so that's a good check. 1, that is the perfect square of 1. Now let's double check. If we take the square root, which is 3x, we take the square root of 1, which is 1, and multiply those together, I get 3x. If I double the 3x, do I get the middle term of 6x? Close. Close. I know that if I had 3x and 1, multiply those together and double it, I get 6x. The middle term here is negative 6x. Well, that's because the one part here on the end is the square of 1. It is also the perfect square of negative 1. If you take negative 1 and square it, you still get positive 1. So if I make this a negative 1, now if I multiply the 3x times the negative 1, I get negative 3x. Doubling it gives me the negative 6x. So this is a perfect square trinomial. And guess what? By writing it the way I did it, it's already almost in factored form. Technically, it's 3x minus 1 times 3x minus 1, or 3x minus 1 squared. So again, this is a lot about pattern recognition. Can you recognize the patterns of what's going on here? You got to be able to see your perfect squares, and there is a little bit to the patterns. So again, if it's going to be a perfect square trinomial, check the ends. Check the first and last term. Are they perfect squares? If you were to take the square roots and multiply them together and double it, does it give you the middle term? If it does, it's a very simple factor. That's how you would factor a perfect square trinomial. Okay, let's try one more. Let's give another example. This one's a good one to at least keep working on. So let's have 25x squared plus 30x plus 9. So let's double check. If this is a perfect square trinomial, that has to be a perfect square, and so does that. Well, 25x squared is the perfect square of 5x. 9 is the perfect square of 3. Multiply 5x times 3 and we get 15x, and double it, we indeed get that middle term of 30x. These are all positive, so that is a plus. There's a squared. We're done. That is the factor of the perfect square trinomial. All right, that takes us through the first two topics. So now let's talk about second degree polynomials. which is just quadratics or something where you've got x squared. Technically, what we've been factoring here are second degree polynomials. These are just special cases of them that makes it a little bit easier. Sometimes it won't fit into the category of being these perfect squares, perfect square trinomials or something like that. So we're going to go ahead and factor some easier ones where a is equal to 1, and then we're going to jump to some ones where a is greater than 1. So this is going to be topic 3. Factoring a trinomial. Where a is equal to 1. And by the a, I mean the form that we have ax squared plus bx plus c as your trinomial. So the constant coefficient out in front of the x squared is going to be 1. Okay, so if we wanted to factor something like x squared plus 7x plus 10. It really does help to understand the FOIL process. That's the way I explain how to do this. Basically, this is going to become two binomials. I know that in order to get this first term, my first components have to be x and x. There's really just no other choice. In order to get this last term in each one of these parentheses, it comes from the factors of 10. 10 has 4 factors, 1 and 10, and then 2 and 5. The idea is, what of those factors that when I do the outside and inside process are going to give me a sum of 7x? What do I mean by that? Let's try the wrong one first. Let's say that this is 1 and this is 10. If I were to check by doing a FOIL operation, the outside is going to give me 10x when I multiply it. The inside is going to give me 1x when I multiply it. There's no way I can add the 10 and the 1x and get that 7x there. So that is the wrong combination. So let's get rid of the 1 and the 10. So let's then try the factors of 2 and 5. Now if I check, I've got a 5x when I multiply those. I've got a 2x when I multiply those. If I add those together, I indeed do get the 7x. So ultimately what you are looking for, and this is probably one of the easier ones to do, when the a value is 1, when the coefficient here is 1, you're just looking for what multiplies to give you the constant, but adds together to give you your x term. That's all you're looking for. So I'm going to have a plus 2 and a plus 5. So x plus 2 and x plus 5 are going to be your factors, because when you check, the 2 plus the 5 are going to give you that middle term of the 7. Okay, those are by far the easier ones to do. I'm not saying that every one of them is going to be easy, especially because sometimes the numbers, the constant numbers can get a little big, but for smaller numbers, most of us are probably okay with doing some basic multiplication and addition. So let's try another one. Let's try x squared minus 6x plus 8. Again, the coefficient out in front of the x squared is a 1, which means it will always start off this way. X and x in the first entries. So the question is, what multiplies together to give you positive 8, but adds together to give you negative 6? Well, I can't take two positive numbers multiplied together and then add two positives and get a negative, but I can take two negative numbers multiplied together and add two negatives to get a negative. So that means that both of my answers here are going to have to be minuses. And hopefully it's relatively obvious that 2 and 4 are going to multiply to 8, but add to 6. The other factors of 8, of course, are 1 and 8. Those would not add to 6. So that one would be factored. Okay, let's try one more. So let's do x squared minus x minus 12. Again, the number out in front of the x squared is a 1, so it's got to start off with x and x. Now, are there factors of negative 12 that can add to negative 1? Well, remember, to get a negative, when you multiply two numbers, you have to have opposite signs. So we're going to have a positive and a negative. So I'll put a plus and a minus because we have to have that. Well, let's see. There's a lot of factors of 12. 1 and 12, 2 and 6, and 3 and 4. If I take 1 and 12 and I subtract a 1 and 12, I can get to 11. I can't get to 1. If I take 2 and 6 and subtract the numbers, I can get to either 4 or negative 4. Can't get to 1. So it's got to be the 3 and the 4 combination. If I take 3 and 4 and subtract them, I can get to 1 or negative 1. So I want the middle number here to be a negative, which means that my 4 has to be the negative and the 3 has to be the positive. Now, if you go and double check your outside and inside, the outsides would give you negative 4x, the insides would give you positive 3x. Adding those together would give you the minus x. That's factored. All right, this video is running a bit long, so we're going to come back and do a second video on this particular lesson as far as doing the factoring, and that should wrap up 3.2.